Hello, my name's Paul Szymanski, and I'm going to talk to you about a piece of software algorithms that I've developed called SHIVA, Space Highest Information Value Assessment. And essentially, it's a tool that tracks information across the battlefield, whether the information is generated in space or transmitted or generated on the ground or by other terrestrial means. And it looks at the sensor to shooter network of this information and does joint targeting, where you can decide where's the best place to attack this information in space or on the ground. So the purpose originally was to quantify the impact of space on the battlefield. That's a difficult thing to do because space is mostly information being generated and transmitted. So it's hard to tell if an adversary commander had this information and he attacked left versus right, or if you denied it or delayed it. What's the impact on the battlefield? It's very difficult to model a human mind and to try to really understand the value of space. Exactly. So it shows the flow of information on the battlefield and the value of information to battlefield decision makers, whether space or terrestrial base. And it's an integrated targeting tool. Uh, it gives a common measure of merit for both space and terrestrial targeting of the flow of this information. You can also model future command and control networks with this software where you insert new sensor systems and command and control systems and look at the flow on the battlefield, the probability information received, the timeliness, and the vulnerabilities with this Shiva software. So it's objectives based. It's a strategy to task kind of setup. So you put together what are the blue objectives on the battlefield, link those to red objectives. You want to know what are the most vulnerable parts of the information network for the blue side, and you want to be able to target red. And you might be targeting different sensors or command and control or communication, but you're really targeting the objectives and the information that's supporting those objectives. And so each objective has to have certain information requirements. If the adversary needs to know what's the best way to attack, he needs to know what's the trafficability of the soil? Is it too muddy for tanks? What's the location of enemy forces? What's the location of my forces? Where are the roads? Where are the forests, the mountains, and all kinds of information he needs to know in order to make an effective attack. So what this Shiva software does, it links then these information requirements supporting military objectives and says, okay, we link it to the sensors and then we look at the sensor to shooter flow on the battlefield. Let me show you that more specifically. So you have both red and blue military objectives. There's certain information that are required in order to achieve those goals. There's certain sensors that detect that information. Each sensor downlinks raw data, and so needs to be processed and then transmitted to an intel center that summarizes it, gives that information to the commander at some sort of command center. He makes a decision and he directs forces based on that decision. So that's the sensor to shooter network. And there's certain success criteria associated with this. What's the probability that the adversary commander or the blue commander uh, receives the information? What's the overall time delay? Does he receive it in a timely manner? And what's the total number of paths that this information flows on? Different sensors can detect the same information. There's different networks on the ground and in space. And so it looks at the entire network. And there's one common measure of merit. Did the adversary commander or the blue commander receive the information? Was it correct? Did he get it in time? And was he able to support his decision making and direct his forces? So maybe he received the information, but just spoofed it. It's incorrect. You denied information paths with correct information, and you inserted incorrect information in paths that you allow to get to the adversary commander. And then the adversary commander might have all the information in the world and making great decisions, but If he's cut off from his forces, he can't direct him. So this whole concept of sensor to shooter in order to make the OODA loop, so to speak, observe, orient, decide, and act. And this analyzes the total networks, whether space or ground, and provides a common targeting tool for that. So the benefits, it shows the impact of space systems on the battlefield in terms of decision making by commanders. And you can look at optimized targeting of red assets or vulnerability of blue assets that might require additional paths or additional defenses associated with it. It's integrated targeting, both space and ground. It benefits, shows a benefit of information operations in the terrestrial air tasking order, space tasking order, and so forth. And then you can show the impact of new programs and how they will improve the probability and flow and timeliness of this information on the battlefield. So it demonstrates to warfighters the value of space. It shows which are the choke points of information for, let's say, more detailed analyses. You can input this to campaign models. You can do what if analyses. If we deny this path or strengthen this path, what is the overall effect? Especially looking at alternative ways for the information to get through. And then, if nothing else, if you show these are the prime paths and the prime nodes in these paths, you could task Intel to really observe those different nodes and paths and understand better targeting, or maybe do signals intelligence or whatever. So there's all kinds of databases that have been available. This SHIVA software links in automatically to standard Department of Defense databases of links and nodes. And there's also a worldwide open source database that's already actually in there. And these Pacifica, Corona, SHICAN, these are military theoretical unclassified scenarios that the software has been run in. In addition, this SHIVA software has been reviewed and validated by the RAND Corporation many years ago. So there's various rankings that go into what is the top target you should take out. So how important is the information flowing through that node? How much the node is a choke point? Maybe it all comes through one area. You take that out and you've taken out 90% of the pass. What's the actual value of the intelligence flowing on there? What are the total number of nodes? How many fiber optic networks? How many communication satellites and so forth? And then some nodes are more reliable, more capable than others. And what is the overall probability that the information will flow through that whole path? Maybe if you've got an imagery sensor, it only comes over maybe every 12 hours or more. Is that going to be timely? What's the probability that you're going to get that information correctly? What's the probability that sensor's actually going to see what you want to see, and so forth? So if you've got any other additional questions, this was just a summary briefing. You can contact me at national@policy.space. That's my email. I'm also on LinkedIn. I run a space warfare unclassified discussion group on LinkedIn with close to 24,000 members on that. And I've also published some books and some new books coming out on how to fight and win space wars. So if you have any additional questions, please contact me, and I'm available for consulting services in the area of space warfare. Thank you for your time.